Hey everybody! First of all, I gotta say that it is an honor and a privilege to be with you today to talk about a Cloud Foundry approach to data modernization. As mentioned, my name is Gregory Green, and I've started out my career as a sort of a software development generalist. Nowadays, I focus on the data side of application data development. And I've been blessed over the years to be able to recognize common patterns or data patterns to solve specific problems. And oftentimes, I'm pulled into conversations with our customers, and I look at what I would say their current architectures. And sometimes I'm surprised. Other times I am shocked at the old versions that our customers are using in production for their applications, right? And many a times they have a mindset: if it ain't broke, don't fix it, which in principle sounds good, but I don't know about you. I've never had a computer or a laptop that I've never had to fix, enhance, or replace, or software that I never had to fix or enhance over time. So when these old systems break, because like I said, they probably will break, it just becomes harder to repair, to enhance, and ultimately replace these systems, right? And when they break, right? Again, it ultimately just makes it harder to maintain these old systems. So, one of the major benefits, I would say, of Cloud Foundry is it kind of forces you to maintain a modern solution, right? It supports ways for you to easily deploy your enhancements, your application, your latest application code, like was mentioned many times before I came up here about the CF push experience, right? And also, I believe that it uses very simple terms. There's applications, then there's services to support those applications, right? Again, which is really easy to understand. And as compared to, I would just say, other containerized solutions. And I probably won't be the last person to say this, but it is the best place to run your Spring applications. Thank you. I got somebody in the corner that agrees with me. Because it just knows how to enable things like actuator endpoints for your apps, where it knows that, hey, your app is ready for processing, but also as your apps are running over the course of time, it knows that it's still healthy, and when it's not healthy, it knows how to repair it. Now, this is not extra configuration that you need to add. It's all kind of that knowledge is all baked into the platform, right? And it probably knows Spring better than a lot of your application developers and administrators. It makes it easy to expose your applications or your web interfaces with zero downtime when you need to upgrade them or to scale them to meet increasing needs over time, right? But I'm here to talk about your data, right? So, what about your data? I've witnessed many of our customers, they start by moving their applications to the platform, but often they may keep the data in those existing data repositories. And when this happens, I've also witnessed a kind of a cultural war develops where you have the traditional data mindset and they kind of fight against the modern application mindset, right? Do I have any DBAs in the room? Okay, if I did, I was going to say they are awesome, they are amazing, but often they want full control over their systems. They want either full control or no control. And application developers, do I have application developers in the room? Okay. Application developers, you want freedom, right? You want access to the data that you need without the bureaucracy and without the red tape, right? And I'll just say that having control over the data is important. It's essential, especially based on the type of data, because there's some data that is very sensitive, right? There's some data sets that probably should never go to the public cloud, right? Because of compliance reasons and so on and so forth, right? So if anything happened or any exposure happened, it would not be good. It would actually be detrimental to your entire corporation. So, due to these factors, data kind of gets stuck in those old systems on the monolithic databases with that traditional database mindset, and it may be a roadblock or stunt the growth of application development and innovation. So, if you are open, I would like for us to explore opportunities to use Cloud Foundry to unlock that data, that traditional data mindset, and allow you to continue to maintain control over your data systems. Now, who here is using Cloud Foundry today? By a show of hands. All right. So, for those of you who are using Cloud Foundry today, are you using data services on Cloud Foundry on the platform? Anybody? Okay, got a few. Um, Now, not everybody who said they're using Cloud Foundry raise your hand when I asked, are you have data services on the platform? And I get it, right? You probably need a compelling case to move those data services over to a cloud-based solution like Cloud Foundry. And if you have an ever-growing number of applications or microservices-based applications, I'll just tell you that you can go from days to minutes to create your data services, right? Your messaging solutions or your various types of databases with a single click of the UI or a single command or this CF create service command. And behind the scenes, this is using something called the Cloud Foundry tile. And this service that's created, it's not just a hello world example of these data services, right? The tile knows all of the best practices to include in the deployment for you, right? And now you're able to scale your data services just as easy as you can scale your applications. And it's secure by default, right? And it simplifies the time and the effort that you need in order to maintain it over time. And it's going to allow you to maintain control over your data, and it will delegate or all of those repetitive, boring operations that you have to do, like high availability, fault tolerance, disaster recovery. It does all of those things for you, right? So if you have been stuck in that traditional data mindset that has blocked application innovation, there's no better day to start planning your modernization than today because it's Cloud Foundry Day. All right. So now that I've totally sold you on moving those data workloads to the platform, now let's talk about how or the process to get you over to this awesome platform, as Deco mentioned, is absolutely amazing. Now, I am an advocate of keeping your applications and your data together. To me, it just doesn't sound natural to separate the apps from the data that it needs, right? Because I can't think of a useful application that doesn't use data in some way, shape, or form. And so a typical good first step to moving your data to the platform is using something called a cache or a caching solution like Gemfire or Valkey, which is based on Redis. Now, both of these are in-memory based databases. So they provide extremely fast read access to your data. And when I say extremely fast, I'm talking about sub milliseconds response times, right? Because everything's all native on the platform. And also, this is typically the first step to moving your data. Your data, the actual system of record might still be outside of the platform, right? In that legacy data system. So how can you get that data to the cache and benefit from the extremely fast read access, right? So this is where we start getting into patterns. The first pattern I want to talk about is the look aside a pattern, right? Now, with this pattern, what it allows you to do is gradually move that data from the external system onto the cache. So imagine you have a Spring Boot application and it's coded to query some data from an external database, right? And just sometimes it's slow. And maybe you may have challenges to figure out why is it slow. But what you could do, you can use Spring projects like Spring Cache, where you can add a simple annotation on that method. So the first time you try to access that data set, it will be slow, right? Because it's going to go to that external database, right? But after it gets the results, it's going to put it into the cache. So all subsequent calls are now going to be very fast because that data is going to be retrieved from the cache. Now, also Spring Cache has techniques that allow you to keep that in-memory data in sync with the external database, right? So you can specify policies like a time to live policy to expire that data, or you can do evictions based on when you know that data has changed. Another pattern is something called the write through pattern. Now, the look aside pattern, it has a problem where the application code has the knowledge to access those external databases, right? So each instance of the application, it basically does the same thing, or it carries this technical debt, meaning that everybody's got to know how to access the data from this external database. You can shield your code from the knowledge of accessing this external database by loading the reading logic on the cache itself when you're using database technologies like Gemfire, right? In this case, the application code can use a project like Spring Data. And basically, it just accesses the data in Gemfire. And whenever Gemfire detects that that data is not in memory, or what's called a cache miss, it will actually go to the system of record and load that data into memory for you. Now, with this approach, this read-through approach, this has all of the benefits of a general abstraction layer, but at scale. So now every instance of the application benefits from the read-through pattern. And when you onboard new applications and they access the same cache, guess what? They all benefit from this read-through implementation. Now the look aside cache and the read through pattern, they both do something called lazily load that data, meaning the first time you access a particular data set, it will always be slower than the subsequent reads, right? Or reading from the cache. So what many people do is they implement a batch pattern where they load that data based on a schedule onto the cache. Now, this pattern is great, especially for data that does not change often. So think about those data sets that only change maybe daily or weekly, right? So for those, you can use another Spring project or another Spring framework called Spring Batch that runs natively on the platform, and you can wrap a nice interface on top of Spring Batch with another project called Spring Cloud Data Flow, right? In order to run those batch processes on the schedule. And again, it's all running on the platform, and it's going to provide you consistently fast read access because now all of the data is going to be loaded on the platform in batch. Now, another improvement on top of the batch process is using the write through or the write behind pattern, right? The first of all, the previous patterns that I talked about, they all focus on reading the data. And I'm sure you're wondering, right, what about if your application needs to modify or write the data? Well, Gemfire supports the write through or the write behind pattern. Similar to the read through pattern, the cache is provided with the implementation logic in order to synchronize write operations with the external database, right? So the write through is a synchronous update to the external database versus write behind is asynchronous. Now, using these patterns, it depends on, or it's kind of dependent on your ability to introduce a new interface to accept all write operations. And this is often called a anti-corruption layer, right? So the anti-corruption layer on this new service, it will put all of the writes on the cache first, and Gemfire itself will either synchronously or asynchronously update that legacy database or the system of record. But it's not always an option to funnel all write operations to a new service or that anti-corruption layer, right? So, as an alternative, you can use this pattern, the broadcast pattern. With this pattern, you basically enhance the system of record such that it will publish changes to a messaging solution like RabbitMQ. And there are projects within Spring, like Spring Cloud Streams, and it can, along with Spring Cloud Data Flow, it allows you to build a pipeline of applications that will consume, process, and write that data to the cache to meet whatever business requirements that you have. Now, this approach is a major improvement over the batch approach because the changes that are made the changes will be synchronized to the batch in real time, right? Now, one challenge with the broadcast pattern is that you need to modify that that legacy database or that legacy system, right? And that may not be an option, especially if you're using a commercial off-the-shelf product, right? You don't have the source code to update that existing system. But what you could do, you could introduce things like database triggers and have some sort of custom solution to try to figure out changes. But the best approach is to use an out of the box change data capture convention, right? And in Spring, Spring has the Spring Cloud Stream applications, which are basically out of the box pre written applications. They're sort of like connectors. And one of them supports the Benesium framework. The Benesium framework is a great framework to be able to detect changes in the database itself, right? It uses something called in the databases, a write ahead log, right? So all of the changes are just read from that write ahead log and they're pushed to a messaging solution like RabbitMQ, right? And these wall logs or Benesium, it supports most of the major databases like DB2, Oracle, SQL Server, Mongo, so on and so forth, right? But it publishes these changes in real time to RabbitMQ to be synchronized by those Spring Cloud Stream applications to update the data on the platform in real time. So now that you've been convinced to on Cloud Foundry Day to retire those legacy data stores, I want you to get to a point where you have an operational data store that is native to the platform. And it has all of those data sets to support read and write operations for your data domains. Relational databases like Postgres and MySQL are great candidates to replace those legacy databases. And they all run natively on the platform. And if you went down the route of using the read-through pattern and the write-through pattern with Gemfire, well, then you should know that Gemfire can also be used as a system of record to support those rewrite operations for your database or your data operations, just like a database. And you can use your Spring Data project to directly access any one of those data services, and things like the connection details are all order wired into your application for you by the platform itself. Now, you also have the opportunity once you move to the platform to start unlocking the next generation of data patterns, such as data as a service, which is basically implementing microservices best practices, but not just for your applications, but also for your data itself, right? So think about those applications that are orchestrated by Spring Cloud Data Flow. They can expose APIs so that you can ingest that data from external systems, right? And this is going to be done all in real time. And now you can also utilize RabbitMQ as a layer for systems that need to consume that data outside or inside of the platform. RabbitMQ has a technology called RabbitMQ Streams, which means that every message is treated as an event, an immutable event that can be replayed as needed in order to recreate the current state of your data domains anywhere. And of course, this talk would not be complete unless I mentioned AI/ML, right? And of course, you can have artificial intelligence with using machine learning models, right? Right on the platform itself, as Kurti and Corby mentioned earlier, right? Now, these large language models are amazing, right? They are able to do things and think just like a human, right? And you can provide your applications with direct access to these models right on the platform. Now, again, think about those Spring Cloud Data Flow orchestrated pipeline applications. Now they can start using the power of projects like Spring AI to enhance that data on the fly as it comes into the system. So, for example, you can create that data to vector embeddings. You could do classifications. Think about like fraud detection for financial use cases, or predictive maintenance for logistic use cases, or doing things like natural language processing. You could determine the sentiment of certain texts or summaries or large amounts of text. Again, there's lots of different options that you can unlock with this particular use case. And also, you can use databases like Postgres and Gemfire to provide the models with context. So if that model is asked a question that is outside of the scope of the data that it was trained on, as Kurti mentioned earlier, you can again provide it context so it can improve the accuracy of those models using the RAG process, or the retrieval augmentation generation process. And you can also have your model context protocol clients, or MCP based clients, that allow models to discover and use these data services that are backed by the data technologies running all natively on the platform. So, just to wrap up this talk, I hope that you can see that you can speed up the overall provisioning of your data services using the Cloud Foundry tiles, and this adds extreme stability stability to your solution, and it's all maintained by the platform, right? And you're able to scale your data services automatically, and it's all secured by default. And this allows you to continue to maintain control for your data solutions, which will save you time and cost for your data modernization, right? And that's my time. So connect with me if you have any questions. I'll be here to answer all of your questions. And thank you for the talk.